students, welcome to Xrays Academy YouTube channel. In this session, I am going to discuss electromagnetic waves. In this, radio waves. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one. What are radio waves? Let us discuss. Radio waves. Electromagnetic waves of wavelength longer than about 1 meter are called radio waves. So, electromagnetic waves of wavelength longer than about 1 meter are called radio waves. These waves are produced as a result of charges accelerating through conducting wires and are generated by electronic devices like LC oscillators. Since these waves have long wavelengths, they spread around hills and buildings by diffraction. So these are used for radio, TV, telephone and satellite communications. So radio waves are used for radio, TV, telephone and satellite communications. In nuclear magnetic resonance imaging also we are using radio waves. So radio waves are using in nuclear magnetic resonance imaging. Frequencies from a few hertz up to about 10 to the power of 9 hertz. Corresponding wavelengths are from about 10 to the power of 8 meters to a few centimeters. Usually produced by an AC circuit attached to an antenna. A simple wire can function as an antenna. Antennas containing multiple conducting elements are usually more efficient and more common. So, radio waves can be detected by an antenna similar to one used for generation. See here we are using the radio waves in antenna. Parallel wires can act as an antenna. These parallel wires are acting as an antenna. The AC current in the antenna is produced by time varying electric fields in the antenna. So this produces a time varying magnetic field and the electromagnetic wave, that is EM wave. So as the current oscillates with the time, the charge is accelerated. So in general, when an electric charge is accelerated, it produces electromagnetic radiation. Radio waves are produced by the accelerating motion of charges in conducting wires. They are used in radio and television communication systems. They are generally in the frequency range from 500 kHz to about 1000 MHz. The AM nothing but amplitude modulated band is from 500 kHz to 1710 kHz. So the higher frequencies up to 54 MHz are used for short wave bands. TV waves range from 54 MHz to 890 MHz. So the frequency modulated radio band extends from 88 MHz to 108 MHz. Cellular phones are used radio waves to transmit voice communication in the ultra high frequency band UHF, ultra high frequency band. Now I'll discuss low frequency waves, that is EAM band. Radio waves having wavelengths of 10 meters or more are said to constitute the AM band. The lower atmosphere is transparent to these waves but the ionosphere reflects them back. A signal transmitted from a certain point can be received at another point in two possible waves directly along the surface of the earth and after reflection from the ionosphere. It's called the sky wave. Now discuss MCQs. First one. Electromagnetic waves of wavelengths longer than about 1 meter called radio waves. Second one. What is the frequency range of microwave? 10 to the power of 9 Hz to 10 to the power of 12 Hz. Now discuss microwaves. Microwaves. Electromagnetic waves with wavelengths in the approximate range of 1 mm to 0.3 meter are microwaves. This frequency range is 1 GHz to 3 GHz. So discovered by Hertz. These are produced by special electronic devices called klystrons and magnetrons. Because of their short wavelengths, they travel a beam in a signal. These are used in radar systems for aircraft navigation. So, for studying atomic and molecular properties of matter, used in radar and telecommunications. So, to analyze the fine details of the molecular structure. Based on the microwaves, speed guns are designed which are used to time fast balls and in tennis services and automobiles. Tennis serves and automobiles. Microwaves produce heat when absorbed by matter. Microwave oven is a domestic appliance to cook food items. Water molecules vibrate in the frequencies of the order of microwave frequencies. So, frequency of water molecule is 3 GHz. The frequency of microwave is selected to match the resonant frequency of water molecule. When such waves pass through water, the kinetic energy of the waves are efficiently transferred to the water molecules. This raises the temperature of the water. So, this rises the temperature of food containing water. The food materials are to be placed in porcelain container. So, the molecules in the porcelain container vibrate with much smaller frequencies because large molecules vibrate with much smaller frequencies. So, it cannot be absorbed microwaves as they are of smaller frequencies. Hence, the container is unaffected and becomes cool. So, when a metal container is used, it may accumulate some charges and there is a danger of getting shock when touched. So, the heat developed in the container may sometimes melt it. So, based on the microwave, speed guns are designed which are used to time fast balls and in tennis house and automobiles. Microwaves have frequencies between 10 to the power of 9 Hz to 10 to the power of 12 Hz. Corresponding wavelengths are from a few centimeters to a few tenths of a millimeter. See, this is a microwave. Microwave oven generate radiation with frequency near 2.5 into 10 to the power of 9 Hz. This is a microwave oven. So, this generates with a frequency near 2.5 into 10 to the power of 9 Hz. The microwave energy is transferred to water molecules in the food and heats the food. Microwave oven. Microwave oven is a domestic appliance to cook the food items. All the food items contain water as a constituent. When the temperature of a body rises, the energy of the random motion of atoms and molecules increases and the molecules travel or vibrate or rotate with higher energies. Frequency of rotation of water molecules is 3 GHz. The frequency of microwaves is selected to match the resonant frequency of water molecule. When such waves pass through water, the kinetic energy of the waves are efficiently transferred to the water molecules. This raises the temperature of the water. The food materials are to be placed in porcelain container. The molecules in the porcelain vibrate with much smaller frequencies because its large molecules vibrate and rotate with much smaller frequencies. So, it cannot absorb microwaves as they are of smaller frequencies. Hence, the container is unaffected and it is cool. When a metal container is used, it may accumulate some charges and there is a danger of getting shock when touched. So, the heat developed in the container may sometimes melt it. So, the heat is directly delivered to water molecules which is shared by the entire food, unlike in the conventional heating. In the conventional heating, the vessel on the burner gets heated first and then the food inside the because the transfer of energy from the vessel. Now discuss MCQs. First one, electromagnetic waves with wavelength in approximate range of 1 millimeter to 0.3 meter are microwaves, X-rays, gamma rays, radio waves. So, electromagnetic wave with wavelength in approximate range of 1 millimeter to 0.3 meter are microwaves. Next, microwaves are produced by special electronic devices called klystrons, magnetrons, cyclotrons, both A and B. Microwaves are produced by special electronic devices called klystrons and magnetrons. So that's why the option is D, that is both A and B. The answer is klystrons and magnetrons. Next, now discuss infrared rays. What are infrared rays? Infrared rays, electromagnetic waves ranging all the wavelengths from the short wavelength of microwaves to the red limit of visual light are called IR rays. I are nothing but infrared rays. Infrared rays, electromagnetic waves ranging all the wavelengths from the short wavelengths of microwaves, that is far infrared, to the red limit of visible light are called IR rays, waves, that is infrared waves. They have a wavelength range from 0.7 micrometer to about 1 centimeter. So, to detect the infrared rays, the thermocouples, thermophiles, bolometers, photoconducting cells are used. Now discuss properties. Infrared rays are electromagnetic waves and travel with the speed of 3 into 10 to the power of 8 meters per second. Infrared rays obeys laws of reflection and refraction. Infrared rays can produce interference and can be polarized. So when allowed to fall on matter, infrared rays produce an increase in temperature. So infrared rays affect a photographic plate. When absorbed by molecules, the energy of infrared rays gets converted into molecular vibrations. So they are scattered less as compared to the visible light by the atmosphere. So hence infrared rays can travel through longer distance. So through atmosphere under the conditions of smoke, fog, etc., nitrogen and oxygen gases are found to be transparent medium to all the wavelengths of infrared rays. Now discuss applications. Infrared rays from the sun keep the earth warm and hence help to sustain life on earth. The coal deposited in the interior of the earth are the result of conversion of the forest wood into coal due to infrared rays. So infrared rays are used in solar water heaters and cookers. Infrared rays are used for taking photographs during the conditions of fog, smoke, etc. Infrared rays absorbs spectrum is used in the study of molecular structure and then to check the purity of the chemicals. Infrared rays are used for producing dehydrated fruits. Infrared rays are used to provide electrical energy to satellites by using solar cells. Infrared rays are used to treat muscular strains. Infrared radiation has frequency from 10 to the power of 12 Hz to 4 into 10 to the power of 14 Hz. Wavelengths from a few tens of a millimeter to a few microns. So we sense this radiation as heat. So black body radiation from objects near room temperature fall into this range. Also useful for monitoring the Earth's atmosphere. Now we will discuss MCQs. First one, electromagnetic waves ranging from the short wavelength of the microwaves to the red limit of visible light are called ultraviolet waves, infrared waves, gamma waves, microwaves. So, electromagnetic waves ranging from the short wavelengths and of the microwaves to the red limit of visible light are called infrared waves. Next, infrared waves obeys laws of reflection, refraction, interference, all the above. Infrared waves obeys laws of reflection, refraction and interference. So all the above. Now discuss ultraviolet rays. What are ultraviolet rays? Ultraviolet rays. UV is an electromagnetic radiation beyond the violet end of the visible spectrums. Its wavelength ranges from approximately 380 nanometers to 0.6 nanometers. Now discuss properties. Ultraviolet rays are electromagnetic waves and travel at the speed of 3 into 10 to the power of 8 meters per second. They also obey the laws of reflection and refraction. They can also undergo interference and can be polarized. When allowed to fall on metals, they cause the emission of photoelectrons. They can affect a photographic plate. Ultraviolet rays can cause fluorescence in certain metals. Ultraviolet rays cannot pass through glass, but quartz, fluorite and rock salt are transparent to them. Ultraviolet rays possess the property of synthesizing vitamin D when the skin is exposed to the sunlight. Now discuss applications. Ultraviolet rays are used for checking the mineral samples by making use of its property of causing fluorescence. Ultraviolet absorption spectra is used in the study of molecular structure. Ultraviolet rays destroy bacteria and hence it is used for sterilizing surgical instruments. As ultraviolet rays can cause photoelectric effect, they are used in burglar's alarm. Ultraviolet light has frequencies from about 8 into 10 to the power of Hz to 10 to the power of 17 Hz. Corresponding wavelengths are about 3 nanometers to 400 nanometers. The UV portion of the spectrum is commonly subdivided into several regions, that is 350 nanometers to 400 nanometers. UVB is 280 nanometers to 315 nanometers. UVC nothing but 200 nanometers to 280 nanometers. Greatest potential for damaging tissue. Now discuss MCQs. Ultraviolet rays can cause dash, which are used in burglar alarms, interference, reflection, refraction, photoelectric effect. Ultraviolet rays can cause dash, which are used in burglar alarms, that is photoelectric effect. The wavelength range of UV rays is approximately 380 nanometers to 0.6 nanometers, 0.7 micrometers to 1 centimeter, 1 gigahertz to 30 gigahertz, none of these. The wavelength range of UV rays is approximately 380 nanometers to 0.6 nanometers. Now I will discuss X-rays and gamma rays. What are X-rays? X-rays are electromagnetic waves with wavelength in the range of approximately 10 nanometers to 10 to the power of minus 4 nanometers. These are produced when high energy electrons bombarding a metal target. So these are very penetrating and dangerous. These are used to study crystal structure in the treatment of certain forms of cancer. What are gamma rays? Gamma rays are the electromagnetic waves of uppermost frequency range of the known electromagnetic spectrum are called gamma rays. Their wavelength range from approximately 10 to the power of minus 1 nanometers to less than 10 to the power of minus 5 nanometers. These are produced in certain nuclear reactions. Cosmic rays from outer space is also a major source of gamma rays. They have same properties as that of X-rays. So these are used to find flaws in metals and sterilize equipments. These are used to kill cancerous growths. Now I'll discuss MCQs. X-rays are produced when dash electrons are bombarded with a metal target. Low energy, high energetic, low momentum, none of these. X-rays are produced when high energetic electrons are bombarded with a metal target. So the answer is highly energetic. Next one. The electromagnetic waves of frequency range of electromagnetic spectrum are called gamma rays. Lowermost, uppermost, visible, none of these. The electromagnetic waves of uppermost frequency range of electromagnetic spectrum are called gamma rays. Now discuss propagation of radio waves. How does the propagation of a radio wave takes place? Propagation of radio waves. Let us discuss. Low frequency waves, that is AM band. Radio waves having wavelengths of 10 meters or more are said to constitute the AM band. The lower atmosphere is transparent to these waves, but the ionosphere reflects them back. A signal transmitted from a certain point can be received at another point in two possible ways: directly along the surface of the earth and reflection from ionosphere. Waves having frequencies up to about 1500 kHz are mainly transmitted through ground because of low frequency sky waves lose their energy very quickly than the ground waves. So therefore, higher frequencies are mainly transmitted through the sky. These two regions of the AM band are called medium wave and short wave bands respectively. So high frequency waves, television transmission. Above a frequency about 30 MHz, the ionosphere does not reflect the wave towards the earth. So the television signals have frequencies in the range 100 to 200 megahertz. Therefore, a TV transmission via sky is not possible. Only direct transmission via ground is possible. So therefore, in order to have larger coverage, the transmission has to done through very tall antennas. The height of transmitting antenna for TV telecast is given by h is equals to d square by 2, or where d is the radius of the area to be covered for TV telecast and RE is the radius of the earth. Now I will discuss MCQs. The television signals have frequencies in the range of 200 to 300 megahertz, 300 to 400 megahertz, 100 to 200 megahertz, none of these. So the television signals have frequency in the range of 100 to 200 megahertz. Waves having frequencies of about 1500 kHz are mainly transmitted through ground because low frequency sky waves dash very quickly than the ground waves. Gain their energy, lose their energy, conserve their energy, none of these. Waves having frequencies of about 1500 kHz are mainly transmitted through ground because low frequency sky waves lose their energy very quickly than the ground waves. Thanks for watching this video.